probably you understand by yourselves that I'm not entering into the details of the technique of DRIHM, because I'm too old to do so. There is a lot of people here able to manage computers. I would like only to introduce the DRIHM we had together years ago, and how it evolved through time into a e-infrastructure that we have now. Roughly working, but we have. And why we did so. And I do it with an example, a quite long example. So the part dedicated to DRIHM will be a few short comments at the end of this conversation, but a quite long part will be taken by the example. And the example is able to introduce to you and to discuss with you the concept of the uncertainty we are trying to address with the use of models, a number of models linked together, and why we do so. At the end, we have some short consideration on the use of DRIHM infrastructure with the civil protection purposes, which is slightly different than using e-infrastructure in the policy or in the sound policy of disaster risk reduction. These are the two aims of the DRIHM infrastructure, but the use of DRIHM is different in the two areas. I gave the example of this presentation as an example in a meeting we held in Rome the beginning of October 2011. Please remember the date, the beginning of October 2011, and start checking if you remember something about the end of October 2011 in the DRIHM case studies. You will have to take it. This conference was given to an audience of judges, lawyers, journalists, people on civil protection, no particular expert in the use of the word probability. So I did not use all around this presentation, and I not use today, the word probability, but I substitute the concept with the concept of possible 2,000 identical universes evolving together. In a way, that's a more accessible concept than probability, because it doesn't require mathematics. It requires only thinking in the mind, perceiving the idea of 10,000 universes evolving together, identical. Identical till to the event, because after the event, they are not identical. But you don't know in what universe you are living. So you don't know what kind of universe you will live after the event. Do you agree? Because, no, please. A friend I have there. No? We are a bit so suppose we have, these 10,000 identical universes, obviously, 10,000 identical universes, identical Gulf of Genoa, north of Italy. And the city of Genoa is the gray area up there, in the top northern part of the Gulf of Genoa. Morphology, maybe you can see there, maybe not, because we have a bit too light there. There is a very narrow strip between the Apennines divide and the Tyrrhenian Sea. the distance between the divide till to the sea border, Mediterranean sea border, is in the order of 15, 30 kilometers, and the elevation of the divide is in the order of 1,000, 2,000 meters, in the sense that the slopes are very steep, and the Genoa city stays there at the end of these slopes. If you stick to meteorological perturbation, the typical late fall meteorological perturbation, getting from south humid currents from the Mediterranean Sea, they have to be elevated over the divide, and then, typically, there are humid currents, there is condensation, intense condensation for the process, and intense rainfall frequently they happen there. The most intense rainfall we got recently, we observed recently, was 800 millimeters in 12 hours. Observed 800, like this one. Very small guys will be thrown out with this kind of. We got 800 millimeters in 12 hours. With average intensity, you can calculate easily. And peak intensity during this kind of event, you can perceive easily. The city of Genoa was developed 2 years. Maybe have one image more. Huh? It was developed, that's the city of Genoa through centuries. The top left image is the city of Genoa at the end of the Middle Age. The city is very narrow. But it starts developing because of the commerce and because the industrialization. On the top right image, the city of Genoa is by the end of the 18th century. Then the city is getting greater and greater and invades the alluvial plains of this. There is also is that one? Okay. Invades the alluvial plains of the small river. And that's the event theater of the event I will describe just now. In this event theater, this small river is covered, and it was covered in 1932. So this image is just 5 years after this stream was covered. Now let's go back. And that's the Google image of the last part of this district of the city. You can see, most probably you can see the stream here. This part is visible because it's not covered, but this part is not visible because it's covered. So we have a very large square. It was required at the time by the fascist area to have a large square in order to have most people accessing together to the manifestations. And here we have the soccer stadium. The soccer stadium is just the event theater I will describe just now. And that's the stream mouth. So we have 10,000 universes with 10,000 soccer stadiums near the stream in the 10,000 identical planned and developed cities of Genoa. That's whether you can have an image under this area, the stream is covered, and is flowing under this area. Down there, we have the Apennines, with the divides up to 1,500 meters. The catchment of the stream is in the order of 100 square kilometers, so quite a small, With the response time, someone among you that are hydrologists, the concentration time of this small river, it means the response time for non-hydrologists of the river is around 3-4 hours. It means that the maximum peak of the flood will be developed after 3 hours from the beginning of the intense rainfall. Roughly speaking, not for you, roughly speaking for non-hydrology. And at the entrance, I do hope you can see in a way, the entrance of the cover, the upstream section of the cover. So the torrent, the stream, when it develops a flood, enters the 4 arches down there and flows under the Victoria Square. In the Victoria Square. On the right, you have the full bank level. So until to this level, the stream is contained within its bed, and that you have on the left, the flooding level. Flooding level means the level in which the stream overtops the banks and flows also along the streets and the roads. The specificity of the hydraulic of this kind of section is that, according to the flow of the stream, the level of the stream is increasing. The flow increases, the level increases, until it touches the roof of the cover. When it touches the roof of the cover, meteorologists, they don't know. Hydrologists, maybe they suppose. People in hydrology, they know. When it touches the roof of the cover, and that's the reason we have a link of models in DRIHM infrastructure, because they don't know something, hydrologists, they don't know something, people in hydrology, they don't know something, and we have to connect these people. When it touches, immediately the wetter perimeter of the flow increases, and so with the same hydraulic gradient, the flow decreases instantaneously. It happens there, and so an explosive retrograde wave of flow explodes in the sections, and the current inundates, floods the roads and the streets. Quite suddenly. That's the concept, quite suddenly. Now, go to the event. Let's suppose that in these 10,000 universes we have running together, identical, in 300 out of 10,000, a situation room typical of the civil protection agencies predicts something for the day after tomorrow, for Sunday, like they did in the coast of Spain, south coast of Spain yesterday, like they are doing in Italy, certainly, because I'm sure that there is something there, because there is in Spain, like they are doing everywhere in the world. So they predict in 300 out of these 10,000, probability, frequency you can evaluate in your mind. I don't care. Next Sunday, it will rain for at least 12 hours, and the rain depth will possibly be equal to or exceeding 200 millimeters in the area. in the area in which the city of Genoa is placed, and so we stand on the river. Now, let us choose out of these 300 universities, one at random of these universities. And suppose that the iatrograph that develops in this universe is like this one, slightly exceeding 200 millimeters in 12 hours, but unfortunately, or fortunately, depends, the most part of the rain happens in the first 3 hours of the event. The event starts at noon, and most part of the rain, say 150 millimeters, they rain in the 3 first hours of the event. Then there is a spread of the rain, and that it rains slowly until to the night. That's possible. It's 1 out of 300 of this university. And now go to the city of Genoa, Sunday. On Sunday we used to have we used to play football, play soccer at the stadium, and the special Sunday of the prediction, it was planned to play between the team of Sampdoria, which is typical of Genoa, and the team of Milan. There is a very long hate between these two teams in Italy. So in spite of the rain, because the rain was started at noon, in spite of the rain, the capacity of the stadium was not full. We had only 10,000 people soaked under the umbrellas there, waiting for the play, and at 3 o'clock sharp, like we used in the 90s in Italy, all over the country, the referee comes out with the 2 chiefs of the teams, and as you probably know, I don't know if you played soccer when you were younger, but the referee has to check if it is possible to play, taking the ball, sending the ball on the field. If the ball bounces, that's okay. If not, that's impossible. He does this sequence for 3 times. If for 3 times the ball doesn't bounces, the referee whistles 3 times, and the play is over. It's postponed, or is something like that. We did exactly this. And so the 10,000 people sitting on they start rapidly toward the outskirts of the stadium. And as you saw from the previous image, but you can see also here, to get out they have to I'm doing something wrong. So they have to get out and to run along the 2 roads to get the railway station, to get the buses, to get their car in the park, and so on. There is no space, there's enough space around the stadium to park the car there. But exactly at this moment, in the universe A out of 300, in which the event was announced, it was raining by 3 hours. The rain got more than 100 millimeters, and so the flood developed, and it was at the peak. The water touched the roof of the cover, and an explosive retrograde wave went through this street and washed out these 10,000 people running for their cars. After, in 1 hour, everything was over. At 5 o'clock, in this Universe A, firefighters from other regions, they are still coming to the city of Zero, but everything was over. The hospitals, they are full of injured people. Damage were high, but it was a catastrophe. Something like 1,000 people died in this event, in the Universe A, out of 300 universes, in which a possible flood was announced. Now let's continue to examine universes and go to Universe B. In the Universe B, the lithography is as this. Less than 100 millimeters in the first 3 hours of the event. The event started noon also in this universe. Then a bit of rain, and then the remaining 150 millimeters at the end of the event, after 9 o'clock in the night. So that's exactly the same prediction, but with different hyetograph. And how to predict the hyetograph, I will ask two meteorologists at the end of this conversation. So, describe the event. Teams were there, the people, 10,000 people were there because it was raining, and so on. So, the referee sent the ball didn't bounce for 3 times, he whistled for 3 times, and people get out. But the peak flow of the previous universe was not reached by the train, and so they went to the car parks, very wet. They went to the railway station, all soaked under the umbrellas, but no one died. We had a number of colds, we had a number of problems with their health, but they were not washed out by the stream. But after a few hours, 9 o'clock in the evening, it started to rain intensely. And by around midnight, because the slopes of the Ketchum were already saturated by the previous rain around noon, a flood developed larger than the flood we had in the first universe A. In the universe B, we had the flood at midnight, a bit larger than the other one, and so the stream went up, the water level touched the roof of the cover, an explosive wave of water went on the roads. We had the same damage, but no victims, because it was midnight. Genoese there were sleeping at home, because it was Sunday night, not like in Madrid. In general, they used to sleep Sunday night. It was raining so hard. There were no taxi, no buses, no one around. Also, the burns were out from the underways, so we had no victims. Obviously, if we examine the other 298 universes, we will see different events according to the hyetograph, maybe with some casualties in some universe, maybe without in many universes. what's interesting is that after the event, we verified, together with two colleagues of mine, maybe you remember, Professor Renzo Rosso from the Politécnica of Milan, and he was there from Milan to see the play, and Professor Paola Barbera, maybe you don't. He was there to contrast Professor Rosso because he was also there. They went there, they remained there under the umbrella, and they went out, but they survived. So, because they survived, we know now that we were in the universe B, and not A. If not, two of my colleagues were washed out. So, now, do you perceive how thin is the difference in physics? Compare the iatrographs. Everything is the same. The announce, the total rainfall of the event, the location of the event, which is very difficult to check, to produce. The only difference is that the iatrograph. So it's very thin. And how large is the social result of the event? Compare a catastrophe, a possible catastrophe, with, I'm not talking about probability, you check your probability if you like. The very unfortunate result of this conference I had in Rome, that is a few weeks after, it was beginning of October 2011, a few weeks after the conference, an event, like I described in the conference, hit the city of Genoa. And that's exactly the case study case of the DRIHM in the infrastructure, the first one. It was not exactly a catastrophe, because the coincidence of the people getting out for the stadium and the flood was not, but it was predicted. Warnings were issued the day before. The event happened around noon, with pupils leaving the schools. Unfortunately, we had only 6 casualties. But we had casualties. So people in civil protection, they have to deal with something more than the probability we are able to estimate through chains. People in civil protection have to deal with the, well, that's an history of myself. I will get back. Civil protection people, they have to deal with uncertainty. And because I was involved in the building up the civil protection system of Italy from 25 years ago, this kind of problems were quite clear to a number of people working together at the time. And so we started building up models to get in the models, the meteorological models, most appropriate for the scale of events. It means models with quite detailed output. But we check that the scale of the meteorological models is not the scale of the hydrological ones. Getting together, that's difficult. And to overcome this difficulty, we have to think a lot and to do a lot of work. The scale of the hydrological models is not the scale of the hydrological problems. was quite clear there. The problem was a section of the river, a bit of the river which is covered from the beginning of the past century, when the knowledge of this kind of event was not so high. And so the section of the free for the stream was not enough when it was designed, but it was perceived not enough now. So we are supposed to re-enter in the center of the city of Genoa and destroy the cover. But destroy the cover there is like destroying 50% of the city of Genoa and their connections. So we are still sitting on the problem, waiting for the next event, like we did in 2011. Oh, I had to explain to people in the newspapers and people in TV that give me the conference. I was not giving a prediction. I was only describing a possible event. But the event is so possible that in 3 weeks' time it happens. The Italian system of prediction is quite complicated now because it's distributed in 20, something like 20 regional centers. I don't have exactly 20 or 15. And one central center connecting together in order to choose the regional center to predict the event which is more near to the center in order to be able to connect the meteorological event to the topographic conditions there and to check the risk section of the rivers they have in their regions. The system is formed now, the more than 100 skilled people connected together in order to give the better predictions possible. And the procedure, you know, is extended to Europe through the innovation in the European civil protection, slowly, because Europe is slow. It's not like the United States, as you say in the beginning. But it's presently under transformation as 20. But try to think how to have a center in Europe to make predictions for Europe. It should be a system of people working together with the similar techniques, because everyone in Europe has the right to have the better system possible, the better procedures possible. And that's the reason why I think that the DRIHM infrastructure is in this direction a very promising hotspot in hydro-meteorological research. But now, I suppose you are asking yourselves, why I started this lecture with the example of the city of Genoa and the 10,000 universes. Because I'm thinking that there are still research needs. And because most of you are doing their research in PhD programs, some of you are trying to go to a doctoral or postdoctoral position. I would like to stress that the DRIHM infrastructure does not solve all the basic problems. For example, I'm suggesting that you read a book, The Black Swan of Taleb. Taleb is a philosopher, mathematician. He did a lot of money making prediction of the value of stocks And after making a lot of money, he's teaching in Cambridge, he's teaching also in the New York Polytechnical School, probability and statistics, typically. He wrote a book which is called The Black Swan, the impact of the highly improbable. And try to think back to the example I gave to you. It is highly unlikely, I do prefer to say, highly unlikely that people get out of the stadium and the crosses the river. So the intersection of the two events is typically in the field of the highly improbable, but that's not impossible. I call it the Taleb thesis, or the. It says that the human condition, which the human condition learns from experience, it is forced in the mental tunnel, the prediction of what will happen, in the sense that the highly unlikely event did not happen in the past experience of people, because it's highly unlikely. And so it's out of the tunnel of the prediction. So people in civil protection, they have to use DRIHM infrastructure in order not to avoid, not to consume their time in connecting models, to have time enough to be sitting there and think of the highly unlikely event connected with the prediction they are doing. Observing what possibly will get wrong. Really, playing a football, planning a football play during a very intense event on the area on which we are playing. That's, from the civil protection purposes, quite dangerous. So the social possible impact will suggest that the play is postponed before the event. Play is postponed the day before, to a different day than Sunday. That's very difficult to be accepted by players, by referees, by people want to attend the play with different, but that's a social requirement. That's thinking deeply to very unlikely events. It is required from the civil protection point. So, in synthesis, I no speech about the infrastructure of the game. What is my experience is that when you are doing a lot of efforts in order to connect models from meteorology to hydrological models to hydraulic models, we are spending so much time of your mind resources that in the end you think that what you predict about uncertainty is there. It is there because you have the ensembles connected with the DRIHM infrastructure, if you like. You have the rainfall, how do we call it? Rainfall disaggregation connected possible in the sequence of the DRIHM infrastructures, in the sense that you can take a large part of the uncertainty prediction tunnel, but not outside. What we need is what civil prospection people need is to sit there and think what is outside from the experience of the past, which is dealt with in the sequence of DRIHM, but it is not only DRIHM. If you move in the field of relationship between DRIHM, infrastructure, and the policy of disaster risk reduction, you know, there is an initiative of the United States called UNISDRR. It means United Nations Strategic Initiative on Disaster Risk Reduction. CIMA Foundation is working a bit for this initiative. I had an invitation just yesterday to take part in an advisory group made by older people, retired people, which is the possible role of older people in the disaster risk reduction. My feeling is that they have to stay out from flood. But I got enough of flood. But really, in disaster risk reduction, and in the major topic of disaster risk reduction, there is the climate change impact on possible future disasters. The Taleb effect, you have not to deal with the Taleb effect, because the Taleb effect is already dealt with in the climatic prediction. What's the need? Take the climate prediction at the better scale they have. They are so uncertain that every Taleb effect is done there, upstream of the prediction. What do you need? Why? You need infrastructure. Take the climatic prediction at their better scale, make it possible ensembles there, make possible disaggregation of rainfall there until to the scale of hydrology, and then describe possible scenarios of the future impact of climatic change. And that's the need of a policy for disaster risk reduction. To know in advance future scenarios in order to design infrastructures, to plan cities. Cities they plan by ourselves because so many people are migrating in the world. In the future world that control the migration, that's impossible. But to plan as much as possible, and to, like we didn't make in our past. For example, it was not so costly designing the Victoria district of the city of Genoa to double the section for the river, for the beginning. Now it's quite impossible to destroy the cover and to double because there are buildings everywhere. So we are forced to not to have solution, but planning in advance, knowing scenarios. That's exactly what the sound policy of disaster risk reduction is required. But not only for flooding, maybe for this kind of processes of in between floods and landslides, we are calling mud flows, very destroying mud flows. we had in Brazil recently, 2 months ago. We had on the other side of the Mediterranean years ago, destroying floods a month flow together in the Kashmir or Algeria. 700 people died. 700 is likely catastrophe. I described it for generosity. Planning in advance, like we did not for the past, is possible for the future. Planning for, I was saying, hydrological disasters, but also for other kinds of disasters, including man-made disasters, or disasters are man-made but connected with physical disasters, like we had in Japan a year ago. Okay, that was my idea of the introductive lecture. In the end, to say that we do not have to rely too much on DRIHM infrastructure. It deals with a lot of the uncertainty of the problem we have, but within the tunnel of the prediction, which is typical of this kind of science. And so I wish you to tackle some of the basics topics I hinted here and there during this presentation. I wish you a long career of research and application of the problems you research, like I had. Thank you. If you do you have a question about probability and 10,000 universes? Really? You don't? In the end, you are visualizing. Because that's an exercise. A typical exercise for the mind. No? To see all universes running together and choosing among the universes the scenario you will have, or the best scenario you will have, the wrongest scenario you will have, and then make your choice. And also for civil protection, every operator of civil protection, they have to make their personal choice. And so procedures are very useful to help people to think, and not to take a given result, given the procedure. Because if so, people in civil protection are useless. But their mind are useless. They can sit there and think, and the computer will go alone without people sitting there. Questions? So I save you 10,000 minutes to relax. Thank you very much.